So continuing on with section 1.2, we need to talk about a postulate or an axiom. Postulate or axiom, they're two words for the exact same thing. Okay? Two words for the exact same thing. Postulates, we're going to call them postulates in this class, but axiom is another same word. So postulates are just rules that they are what they are. You can't prove it. It's just a rule. It is what it is. Okay? For example, the color blue. Blue is it's a postulate in your life. In fact, all colors are postulates in your life. You can't prove them. Okay? You know that my shirt is blue and white because somebody told you, hey, that color right there, that's blue. And you went, okay. That's it. You know that that color right there is black. Why? Because somebody told you to call that color black. And you said, okay. Now, once you've named it, we can now talk about the properties of it because you guys hopefully all know that light is all because of light waves coming through, and right, the different wavelengths of light make the different colors that we see. We don't see without light. Okay? We can start talking about those properties. Those we can prove. But the actual color, the name of it, and a good rule of thumb is if you know somebody who has been blind since birth, they have never seen something a day in their life, try to explain to them what blue is. It's not going to happen, right? You can't do it. So that's a postulate. That's just a rule that is, because I say so. Well, somebody else says so, right? So that's what postulates are. Just rules that you say, okay, that is okay, so that is what it is. We agree on it, we move on. Okay? So we're going to have a few postulates today that we're going to talk about. And let's see here. Postulate 1-1. Postulate 1-1, you've actually used this postulate before in Algebra 1. Okay, when you graphed lines in Algebra 1, you took an equation, you found its y-intercept, you plotted a point there, and then you counted its slope to another point, you plotted a point there, and then you drew a line through those 2 points, right? That's how you did it. Well, postulate 1-1 says, through any 2 points, there is exactly one line. And the whole point of that is, when you plotted those 2 points, you drew a line. You got the same line as anybody else who ever plotted those 2 points in the history of the world. There's only one line that went through those 2 points. Okay? So that's our first postulate. Through any 2 points, there's a line. There's exactly one line. Postulate 1-2. If 2 distinct lines, meaning 2 very different lines, if 2 distinct lines intersect, then they intersect in exactly 1 point. Okay, if 2 lines intersect, they intersect at exactly 1 point. So for example here, line AE and line DB, they intersect, and so there's a point there and we're calling it C. Now, one thing I want you to look at this diagram, or want you to see here, is that there's no dot where that point C is located. Well, it is a real point. It is a real point, but remember from your definitions of points, points really don't have any size, right? Points are just a location. And by drawing that intersection, can you tell me where point C is? Absolutely. So do we need the dot to show us the location? No. So sometimes you're going to see points just shown as intersections rather than actually a big black dot. Okay, so again, we're training ourselves on looking at these things properly, seeing the diagram that they're actually asking us to see. Make sense? Okay, so if 2 lines intersect, their intersection is a point. All right, and let's see here. Postulate 3. Postulate 1-3. If 2 distinct planes intersect, then they intersect at exactly 1 line. If 2 planes intersect, they intersect at exactly 1 line. And you can see this postulate in action every single time you open a book. The front cover of the book is a plane. The first page of the book is a plane. And where those 2 planes intersect is then the binding, or a line. Okay? That's all we're saying. This plane intersecting with this plane gives us a line. Not a point, but a line. You can see that in a room. The front wall and the floor intersect at that line. Or front wall and the side wall intersect at that line. Okay? So if two planes intersect, they intersect at a line. All right, let's try a couple examples here. So, example number 1 here, finding the intersection of two planes. So each surface of this box represents an entire plane. It's not just, the part of the plane. It's going to represent an entire plane. So we want to know what is the intersection of plane ADC and plane BFG. Now, one thing that's nice about this class is you get to draw pictures. Okay? You get to draw in geometry. So if you're working homework and they ask you for this, I strongly suggest drawing the diagram first. Now, if you can't draw very well freehand, then put your piece of paper on top of your book and trace it. I don't care how you get it there, but get it on your paper. Because it's far easier to do this kind of stuff if you can actually doodle on it and shade things, okay? So for example, if I'm trying to find plane ADC, I would mark point A, point D, and point C, and say, well, which part of that box has those 3 points on it? This is just like the homework assignment for 24 and 26 from yesterday, or from Friday. So which part of the box? The top. The top of the box. Now that's, of course, not the proper name of that plane. We can't just call it plane top, okay? So that's not the proper name for that plane, but yeah, you're right. It is the top of the box is what we're talking about here. What about plane BFG? So let's see here. B, F, and G. So which part of the box is that? The right side of the box from how we're looking at it, right? So the right side of the box is this plane here. And we want to name its intersection, which is going to be a what? What shape is the intersection going to be? A line. It's going to be line BC, absolutely. So that line BC, I'm drawing it all the way across for a reason here. I'll talk to you about that. So line BC is the intersection of those two planes. Postulate 1-4 we've technically already talked about, but it is a postulate. I talked about it when we were talking about the definition of a plane. Okay? But remember, a plane is one of our undefined terms. Right? Points, lines, and planes are our 3 undefined terms. And so to explain this, to have this be a rule for us that we have to follow, they made it a postulate. Okay? And so postulate 1-4 says through any 3 non-collinear points, there is exactly one plane. And that's really kind of what I used to make the definition for a plane. I said that we need 3 non-collinear points to name it, right? So this is why. So we know that point Q, R, and S are non-collinear. And so therefore plane P is the only plane that can contain those 3 points. There is no other plane in space that can contain those 3 points, Q, R, and S. Questions? Let's take a look here. So, what plane contains points N, P, and Q, and then shade the plane? So, with your neighbor, or people around you, I want you to name the plane, okay, which it should be easy to name since they're asking you about points N, P, and Q. Hint, hint, wink, wink, nudge, nudge. And then I want you to shade the plane as well. Okay, so discuss with your neighbors, name the plane, shade the plane. Go. Okay, so we need to identify our plane first by looking at the points they're talking about. There's N, there's P, there's Q. Are those points on the same line? No, they are not on the same line, so they're non-collinear. That means we can name our plane simply using those 3 points. Plane NPQ. But there is a 4th point that's labeled on the diagram that also is on that same plane. What point would that be? R. R is also on that same plane. Okay, and so we could have used R in the name, RPQ, okay? And then shading the plane, which part of that box are you shading? Bottom of the box. All right, so this is the plane we're describing. Excellent. Good. Please try part B, again, with your neighbor. I want you to name it, and I want you to shade it. Go. So, looking at this, we obviously know, because looking at points J, I should probably use a different color. Let's use J, M, and Q, that those are not on the same line, right? So they're non-collinear, so that means we can go ahead and name our plane using those 3 points. So we're talking about plane JMQ. That is all wonderful stuff that we were able to say without even knowing where that plane was, right? Looked at the 3 points we're talking about. We know that they're non-collinear, therefore there is only one plane that goes through those 3 points. And that plane has the name plane JMQ. Okay? But now we have to shade it, which is the hard part. Okay? So what I would do, if I'm looking at this box on the piece of paper here, I would say, all right, well, can I start connecting my 3 points? And J and M, that's easy to connect, and I can see that line, right? Because it was a solid line already, so I'm just going to make it solid. Here you got to be careful. We do not want to connect J to Q. Because a plane is, think of it like a big piece of glass that goes on forever in all of its directions, right? And so the edge of that, or the edge that we can see in this diagram, isn't going to go J to Q, because that's passing through this surface, right? J is actually going to want to go to where? P. Down to P. And I know that from looking at the back where M wants to go to P. Or Q, excuse me. M wants to go to Q. J wants to go to P. And then Q and P can be connected. And so our plane is then going at that diagonal through the box. I want you guys to take a look at the bottom set of questions. The bottom set of questions, I want you to answer these 3. Please answer these 3 on your own. Do not consult your neighbor yet. Okay? So, what is the other 2 names for line XY? What are the opposite rays? And what is the intersection of the 2 planes? Answer those 3 questions, and once you have all 3 answered, then you can consult with your neighbor, see if you have the same stuff. So, taking a look at question number 1. What are 2 other names for line XY? Can anybody give me one name? Well, first off, before we go there, XY, correct me if I'm wrong here, we're talking about this line here, correct? Yeah. Making sure we're all on the same page with that. Okay, who's got another name for that for me? Yes, sir.
Line YX.
Line YX, yes, you can just move the letters around. That is okay. But if you did not have it written the way I do right there, capital letters and with the symbol on top, it is wrong. They have to be capital letters and you have to have the symbol on top or it is wrong. Yes, ma'am? Line RY. Perfect, because R is another point on that line. So we can use that point to name it. So RY, again, you have to have the symbol on top or it's wrong. Yes, sir?
Line XR.
Excuse me, line XR could have also been done. Yes. Line XR. Therefore, I'm sure we all see the other combinations here. We could have had line YR, right? We could have had line RX, correct?
Yes.
Any other names that you could think of that aren't represented now? No? Okay, good deal. Make sure you're practicing using proper symbols. What are the opposite rays? Opposite rays, Wiley.
RX and RY.
Thank you for using the proper endpoints. If you look at the front side of your notes, when we talk about opposite rays, you're going to see that we have to have 3 points on our line to talk about opposite rays. Okay? And the end point of our rays has to be the point in the middle of the 3 points. That is our end point. Because then our rays, if we go from R to Y, or through Y I should say, so RY, if that's one ray, then the opposite ray has to start from R and go in the opposite direction, making the full line. So RX. Please remember that the symbols for those rays is always just the bar with one arrowhead. It always points to the right. And the first letter is always the end point of the ray. Always. Okay, it doesn't matter what direction the ray points. The first is always the end point. The second is a point it passes through. The arrowhead always points to the right. Good. Number 3. What is the intersection of the two planes? Before you answer that, can anybody please tell me what shape is that intersection going to be? A line. The shape has to be a line because we're talking about the intersection of two planes. Okay? So, what line?
Line RS.
Line RS. Excellent. Well, I named mine SR. Is that okay?
Yeah.
Absolutely. You can change the letters around for a line. So, line RS. Again, make sure that you put the proper symbol on the top. Any questions over doing this?